Hello and welcome to Tribe Topper. In this video session, you are going to learn about energy changes in simple harmonic motion. As we know, there is a law of conservation of energy which says that the energy just keeps jumping in between one form to the other form, but the overall energy remains the same. So same is valid for this simple harmonic motion as well. As you can see in this image, there is a simple pendulum. So this point corresponds to the mean position or equilibrium position. We know the velocity at the equilibrium position is maximum. So Vmax exists at equilibrium position, or here I can mark it as B. At B, V is maximum, and at A and C, that means at the extreme positions A and C, velocity is going to be 0, because we know that from our prior knowledge that at the extreme positions it stops, it loses all the velocity and eventually falls back. So velocity is 0 at the extreme positions. So what can you say about the kinetic energy? So this automatically tells us, therefore the kinetic energy is going to be maximum at the position B, which is equilibrium position, and kinetic energy is going to be 0 at the extreme positions, which are A and C. Now we talk about the gravitational potential energy. For the gravitational potential energy, the formula is mgh. So mg is anyways constant throughout, but h keeps changing. As you can see from the diagram, that when the bob reaches the extreme position, that is its amplitude position, your height above the ground is a maximum on both sides, at C as well as at A. So at A and C, your h is a maximum. Therefore, the gravitational potential energy is also a maximum at the positions A and C. While at the mean position, we would say there is 0 height above the ground. So the gravitational potential energy is 0 at the equilibrium position, which is B. So you see that energy is just simply changing between the kinetic and the gravitational potential, but the overall value, the total value, would remain the same. And you can easily apply the equation that half mv square, which is half mv max square, the total kinetic energy is, or the maximum kinetic energy is going to be equal to the maximum potential energies. And also the sum of the two, if you talk in between, then what's going to happen? Like I'd say I choose a midpoint here, say D, and here say E. Then what do you expect to happen? At D and E, both the forms exist, the potential as well as kinetic, but the sum of the two is going to be a constant. So we would say the potential energy plus the kinetic energy, which is giving us the total energy of a simple pendulum, that is constant throughout the motion. It can only keep changing. We would say that the energy keeps changing. The energy keeps changing between the gravitational potential energy to kinetic energy, but the total remains the same. So this graphical representation or the graphical variation for this would be like here. You can see this is on the y-axis we have the energy, and on the x-axis we have displacement. So this is the point O, referring to the mean or the equilibrium position. When displacement increases from left to right, your energy starts increasing from 0 potential energy, and it keeps on rising, and at the extreme position A and on the other side negative A, you have gravitational potential energy. And the kinetic energy, which was maximum at the mean position, it starts dropping on either side of that mean position. So whether you go to left or you go to right, your kinetic energy drops to 0. But you can see one line which is a straight horizontal line. This refers to the total energy, and since it is a straight horizontal line parallel to the displacement, which indicates that total energy E remains constant. So this graph represents the variation of energy with displacement, and which you can see that it directly indicates gravitational potential energy to be maximum at the extremes and kinetic energy to be maximum at the mean, but all the time the total energy remains the same. So that's all for this video session. In the next video session, you are going to learn about traveling waves.